Okay, so hi everybody. You to attend my talk. Well, first I'm going to make my presentation. I'm Alfonso Roa. I'm a Scala and Spark developer. I've been using Scala for 7 years. Also, I'm one of the organizers of the Madrid Scala meetup. So if you come to Madrid and you want to give a talk, we'll be glad to have you there. And also, I'm a worker in Habla Computing. It's the company that I currently work. Also, I invite you to the next talk that is from my friend and boss, Juan Manuel, also from Habla Computing. And well, we are here to talk about a bit of Spark. I already asked if you're a Spark developer. I see that not a lot of them. You're lucky. You're not going to have a lot of problems that I'm going to show you. But, well, we have a very small index today. No, it's only 4 points. We are going to talk about a little bit of datasets and DataFrames, what they are about and what problems we can find with them. And then we will see that we are trying to improve the way we work with datasets, DataFrames mainly, for things that we think we can be improved with a library that we've been developing. And we are going to show a little bit, some snippets of the improvements that this library gives. And at the end, I'm going to talk just a little small case that we already developed that we were quite happy with the results. Well, you're in a Scala conference, so I think that I don't have to talk a lot about the Scala type system. We have a great compiler. The problem is that, well, Spark is currently stuck in Scala 2, so we still have the old problems. We cannot get nothing from the new Scala 3, all the context function, missing talk. But well, a little bit is just, well, we have a compiler. The compiler helps us to develop good software. And we are always very happy to use it. But I am a Spark developer, and those that say yes will know this. Problem is that, well, Scala and Spark, Scala is the language that is currently made Spark, but Spark library doesn't use 100% the power of our compiler. And Spark has like two flavors that we can use. In this case, DataFrames and Datasets. We are going to start first with Datasets, maybe the most one, because we have that T, that parameter that we love to have in our compiler. In this case, we will see that, well, the dataset is the container that we use to make all the transformation that we do with Spark. Here, well, it's like a mockup of a process that we can make with Spark that we always start with a data frame. It's when we read a file, when we read a table, when we read a database, we will always have a data frame. And then we can type it. No, we can put it a better type and have a data set. That's the moment that we will have an error if in runtime that the data that we were reading, it's according to the type that we gave, it's correct or not. No? And then we can start to make our transformation. No? We can use map. We have a function called group by key, transform, distinct. And you can see that each time we are going to transform our structure, inside structure. So this is quite good, but when we are working with Spark, it's not as good maybe with the other libraries. But yeah, we have this only moment that we will have a runtime error, or we hope so. And if this moment passes and we don't have any kind of error, we will have a properly running process with the results that we were expecting. But Spark has a few problems. For example, we are talking about big data, no? This big data not only means a lot of rows, also can be a lot of columns, no? A lot of different elements that we want to process. For example, we can have 150 columns. And the problem is that the structure that expects the data frame to become a data set has to be a product, a case class. And we're still working with Scala 2 with the 22 limit problem. And also that we need to create or to model all the steps. Even if we don't use them, we have to model them with case classes. For example, we need to transform column name from name to first name. We have to create 2 case classes. Also, when we are talking about big data, we have to be sure that we are only using what we need. And imagine that we are having here a column that maybe we will need it. We are not sure. At the moment, it looks like it's okay, but we carry it through all the process. And then at the end, we realize that we don't need it. So we will have to change all the steps to be sure that we don't have it. And also the same is at the end. If we need a new column, we will have to add it to the whole process. And it's quite hard to work this way, working with Spark. When we are working with datasets, we will have mixture. Depending on what we are doing, we will have, for example, for map, we are going to use a pure Scala lambda. But in other cases, we will use the syntax that Spark provides us to manipulate columns, that it's the column reference. And we have that mixture that maybe it's harder to understand. It's not pure Scala, it's not pure Spark. It's like Frankenstein between both things. So it's not a great API. I'm talking always about a Spark Dataset official API. And also, well, it has a huge problem. That is the dataset, all the transformation that we are doing with Spark, with Scala lambdas, they cannot be optimized. And that's a really huge pain. It's something that for most of us, it's a no-no. So dataset API becomes into a thing that nobody should use it. And I only have one possible case that I could tell to somebody to use it, that when we need to use a Scala library and we need to put it inside of the transformation that we are doing. So it's something that we have to avoid. There are better alternatives. We have frameworks, for example, that, for example, skips this optimization problem. So it's much better. We will have always our container type, but it won't make any problem to the Spark optimizer. That is pretty neat. So we can go to our data frame, and you will see that compared to the previous photo, it's much nicer. It's beautiful. It's a gray box, or I wanted to put a black box, but it looks always worse. And we can see an example, like the previous one, that it's super happy to work with it. We have a data frame, and we make a selection of columns, and we will still have a data frame. And we can add a new column with the method with column. We still have a data frame. And we can group by, and we still have a data frame, another column, a data frame. We made that distinct. We still have a data frame. It's always a data frame. So we are losing that information about what is inside. And it's not the only problem. I wish it was. But we still have another problem. Well, it's not yet a problem. You will see that in the future it will be a problem. But we have the data frame. Data frame is something that in runtime we will have all the information about what is contained in that moment, what columns have been included, what types of the columns that we have there are present. So the problem is that with data frames, we will work with this way. We have a data frame, and we'll have the column reference that we can make with the call method or with the $sign. And the problem is that we will see that the moment of truth, in datasets, the moment that we make the as, we type the data frame. This moment is when we do the select. We will have the error. It's the moment of truth. If we have that call name or we don't have it. We have an alternative to make these column selections, that is using directly the data frame. With using directly the data frame and asking for column name, in this case, we will have in this line the runtime error. So if this line works, when we make the select, it will be okay. But we have another problem. We fixed one, but we will have another. What problem we will have now? That this column reference is not for any data frame. It's only then for this data frame. No, if you use another data frame that maybe has that column or maybe not, even if it contains this column name and the reference is not exactly the same. So we will have a runtime error saying that this column name cannot be found in this data frame, even if we have this data frame column name. Well, I was talking about selection of columns, but well, Spark, I am always talking about Spark, but I really want to talk about Spark SQL. And as its name says, the nature of Spark SQL is SQL based. In this case, we have another problem. No, we always know that our structure, our schema of the data frame, we will have it in runtime. Okay, it's something that we have to live with. But in this case, we have, for example, a very simple example. Now we have a literal Boolean and a literal integer value. And when we make a literal column reference, we completely get rid of the type, and then we can do everything with them without knowing the type of these columns. And in this case, for example, we will have the Boolean plus int. No, for us, it's quite easy to see that it's something that is not cannot be possible. But the problem is that when we are going to have an error when we do the select, why? In this case, will be a runtime error. No, it's we'll say that you cannot add a Boolean with an integer. Okay, but even the same transformation, the addition, it can become another type of problem. In this case, for example, we'll have a data frame that one of the columns is an integer. In this row, it will be a 1. In this one, is a 2. And we will have another column that is going to be a string. But here we have the representation of 1 and the word 2. And then we can add them. No? We don't have the runtime error as we previously had. Why? Well, it's the SQL nature of Spark SQL, and SQL loves to do implicit conversions. We also in Scala love to do explicit conversion, but I think we know the power and the black magic that is underneath, so we use it carefully. But SQL, not so much. For example, in this case, we'll see that this integer plus string, in this case, we will have a double. There is a 2. And in the second row, the 2 and the word 2 will be a null. For me, it's quite strange. What's happening here? First, why it's a double? Okay. Because Spark, what it's going to do is, okay, this is an integer, not bad. And I found here a string. Spark, if you have tried to make an addition, in this case, I'm going to make an implicit conversion from this string to an integer. Well, not an integer, a double value. Why a double? Because it's always going to be a double. So the result of an integer and a double is going to be a double. Okay, and in the second case, okay, we cannot parse this word 2. It's not so intelligent to become a number 2. So this is going to be a null because it doesn't contain any only numbers. So this is going to become a null, and a null plus 2 is still null. So we have a null. So for me, this is something that I found a lot of times that I'm not sure what type of I have in column. And it becomes a null propagation problem. And we have another error. No, I told you that any kind of reference, literals, whatever, once becomes into the Spark languages or become into a column. And Spark provides us a lot of functions to work with. And everything that is expected is a column, and everything that is returned is a column. So you have to read very carefully the documentation of Spark to know what you can use, what you can't, which function is exactly, because, for example, we have size and length in Spark. One is for arrays, the other one is for strings. So not a lot of reusability. So for me, at least, it's always a personal case. It's very boring, and also for people that come new to Spark, it's especially if you come from Scala and you have this rich type system. So, well, the things that, okay, we have the data frame. The data frame is a type alias for row. Row is like the any inside of the Spark type system. So as we can see in this GIF, if you have something that is typed, but you can put it anywhere, it's like any, and working with any, we don't like it in Scala. So we can see that our ecosystem right now is like this. Okay, we have the container, the dataset and the data frame. And we have also the column references. In this case, for example, for the typed data container that we have, it's the dataset. Work with a typed column, it has to. But, well, the case of a typed container, but untyped references or columns, I think is something that is nonsense. And we have also this data frame in a typed container with untyped columns. It's always a column. You see that this diagram, we can realize, okay, there's a little gap here. Maybe we can fill it with something. So we try to fill this case with a library called Doric. That we hope that is an even better column for Spark. So we are going to try to fix 4 main problems that we find in DataFrames. We have typed columns, type mismatch detection. Also, we are going to try to improve developer quality through faster solving of errors. And we are talking a little bit about modularization. Because I think that Scala is a great language. We can do a lot of modularization. We can do reusable code, but Spark doesn't help us in the way that we work in this asset. So let's see a little bit. Okay, the same example that we previously, only to rephrase it. Now we have this, everything is a column. If it's a Boolean, if it's an integer, if it's a string, everything is a column. So why don't we try to, as developers, give some information of what we not are really doing, with what we are expecting, because the data frame is something that we are going to read, but it always can change. Okay, so we created this Doric column, where you can also provide the type that you're expecting. In this case, if we make a literal integer with a string, or a literal string, sorry, we will receive a Doric column of type string. And also, if we have a integer, we will have a Doric column of integer. The first benefit, okay, we have a compiler, and the compiler will see that this is nonsense. We cannot add a Doric column of string with a Doric column of integer. So we will have a compile error, because we know as developers that we want this to string, and this we want it to be an integer, and we are not going to be allowed to use nonsense methods. So what we can do? Oh, well, instead of working the way that Spark wants, we can choose our own path. We can do for example, we can cast this integer and make it a string. So we will have a concatenation. Maybe it's what I really wanted to do. I knew previously that this was a string, and I wanted to concatenate them. I was expecting that implicit transformation. Or maybe I can do the way that Spark wanted, knowing that maybe we will have some nulls in this case. If we want to transform from a string to an integer, Spark never throws a runtime error in these cases. It will only return a null. So, okay, I can choose what I want to do. Okay, so we already have typed columns, and we will have the Scala compiler working for us since the first moment. Then, okay, we were working with literals. That it was quite easy to see that they were from certain type, no? But when we are working with data frames, we need to reference columns. And in this case, what we are going to do is only add this small snippet of the type that we are expecting this column to be. And we are going to make the selection. No? If we have an error because this column doesn't exist or the type is not the correct one, we'll have here a runtime exception. The same as the datasets we'll have in the as, we'll have it here. And the only two types already said is that we don't have this call name among certain errors. If you're a Spark developer, this is a common error. It's the original error from Spark. And we'll have this new one. That is, okay, the column call name was found, but we were expecting to be a string, but we find a Boolean type, for example, no? Because they provide us the data wrong, somebody changed the schema of our database, and they didn't tell us. So it's great to have this information. Maybe we didn't want to process if they made that change. We only want to process if it was what we were expecting. So to have this runtime exception, it's a great case. So another problem solved, great. Let's move to the next one. Okay, I want to highlight a second that we reduce all the possible, or almost all the possible runtime errors that we can find in Spark. We reduce them to 2, like we do in the dataset, no? We cannot find the column, or we cannot, or the type of the column wasn't the expected one. 2 possible errors. That makes anybody, especially any Spark developer, a lot of peace of mind. We can be pretty sure that if our process is started to do what it wanted to do, it's going to do it properly, and we will have more control. So how can we make this better? We only have 2 types of problems. 2. Okay, so let's make something to fix these problems faster. Okay, for example, we are going to repeat that we want to concatenate our two columns, no? Call name 1, call name 2, and we are expecting that both of them are going to be a string. You have this alias to not be typing all the time, no? Call string. Okay, so in Spark, normally when we have this kind of problem, we will have to run once, maybe it's in your test, maybe it's in your cluster that you have to start up and it takes like 5 minutes, and you're going to wait only to see that C1 has an error. Okay, this column, you miss it. It was like, oh, it needs an underscore in the middle or something like that. Okay, so you fix it in your code, you compile, you upload, you run your cluster again. 20 minutes later, then you find that C2 has another error, no? That this call name 2 also needs an underscore or whatever. Why not give you both errors, no, at the same time? With Doric, we are doing this. What we are doing, it's, okay, I missed that C has to be the addition between them two. But we will have in a single exception both errors. Okay, but why only for one column? No, well, for one column, no. For all the columns that are in your select, for example, no. This one is okay, this one is okay. This one that is a transformation have 2 errors, 1 and 2. This one is okay, and these 2 that are simple transformation that only have 1 column, they're having an error. So we will show you the 4 errors in one single execution. And this way, we wanted to also provide with columns method that allows you to make the with column, but not in a singular way, in a plural way, so we can receive more errors or be sure that in one single step, we are doing everything that we wanted to do. Okay, so I think that this has improved the number of compilation, the number of times that you have to test your code. So great. Another step that is solved. So next step is modularization. And maybe if you're not a Spark developer, you will say, well, why modularization is a problem? We are going to come back to the same error that we have here. It's a very small one, like very easy to see, but we have here an that I told you that, okay, where we have the exception, no? Where is the thrown, this exception is in the select. But the select has two problems, no? That this column, it's wrong, and this column reference also is wrong. But if I see here the problem, I will have to check my code and not debug it, but analyze it with IntelliJ methods, your tool of choice, to find, okay, where I'm making this reference. Oh, this reference I'm making in this line, and this reference is making in this line. And I'm giving you both errors at the same time. So why not when I make this selection, I can save the location of this selection, and I can show you where I made this selection in the code, or in the error, sorry. Okay, so it's something that we are already doing. No, this column name one among column and something cannot be found, and we click here, and we will go to this line. Great. And in this case, also the same. No, if you click here, we will go here. So it's super simple to find it. But in this case, I think that, well, Alfonso, you're making a very complex solution to a very stupid problem. So I want to show you a little bit more complex code. For example, it's quite typical. I saw that there are not a lot of Spark developers, but some companies, they like to hide the implementation. I'm pretty sure that it's not something that only happens in Scala. And for example, imagine that we have this function that our company is providing us, and they don't care about the source code. They don't publish anywhere. You cannot get into this code. They only upload the jar to the Nexus. But they tell you, okay, you're going to process your file, you have to pass through this method certain columns, for example, no? And you don't have any question, you can see it here, but you don't have any knowledge about how it's implemented, what they're using, you don't have the Scala doc, you don't have anything. No, it's quite normal in some companies. And you're in this side, no? Here. And you say, okay, I'm going to use this method, no, common logic for all company. And I pass my integer column as they were saying. Okay, first benefit that we are seeing here. I know that here I have to introduce a column integer, not any kind of column, a column integer. And at least I have what I'm going to return, no? This type of column that is going to be an integer. So, okay, a lot of information that Doric is already providing us, no? It's not a column and returning a column, it's an integer column. So I can be pretty sure that, well, what I'm introducing by myself, I can know that this column is an integer column, so must be the correct one. And when I do this column reference and I launch this select, I will have an error. Why? Because I was only introducing this column, but I didn't know that I needed some columns, no, like an interface in my data frame. No, okay, so here I will have this error, no, hidden column not found among columns. If you work in the Spark, you will say, I don't make this column selection. Where is this problem coming from? It's coming from this element, or maybe other function that I have to use from my company. Where is the real source of the problem? Okay, so we have this location, and we will see that it's something that doesn't appear in our code, and we can say, okay, somebody, you know the common logic number 2? Yeah, we can open you the repo and you can take a look to see the errors. Okay. So this will improve a lot the reusability of the methods, to know exactly which is the source of the error. We don't want to know where we have the error throw. We want to know really where is this one being created, so we can track the real source. If we have to change our data set or we have to change our code. So it's a really good solution. So we have these 4 elements fixed. Well, okay, so we can work better with datasets, DataFrames. So how it's Doric made, no? This is the library that is fixing this one. So it's quite easy. Like this is a simplification, but well, we have the Doric column. They will have this T, and what we'll have inside, it's an element that is a real Doric column from Spark. And what we are really doing is, okay, when you are making a selection of a column, we are not creating a object that is in Spark. It's called like unresolved, because we don't really have the data frame that we are going to work with that column. So we are going to make a lambda, no? In this case, it's a classly, really. That we are in a data set. We work with anything, data set of row or data set whatever. You can still use Doric. And we are going to return this column. And also it's going to be a Doric validated that really is an alias of a validated not entity chain. No, I'm pretty sure that a lot of people will already know what library I'm using here. No, and we will have here a collection of errors or the real column that we are expecting. So I'm not going to delay this more. Yeah, it's really done with cats. No, we are using a lot of cats because it's a great library and it allows us to make all the things that we need to develop Doric. And also we have here an extra one that is location. Location is not present here, but it's using the LiHaoji source code library. It's a great library that allows you to insert the location of your code. No, it's really the main responsible element to have these location errors, and you can click on them and go back to the real source of the error. So it's quite good to work with these libraries. I think that we have a great solution for the data frames. So let's talk a little bit more about Doric now with use cases. Okay, I should say, Doric is super easy to use. We only have to import one single package. No, you import Doric underscore, and you have all the utilities that you will need, except a couple of them we will see later. Okay, so it's quite similar to Spark. We are going to have the call method, but the only thing that you have to provide is this integer. No. Also, if you are putting here integer, Scala will infer the type, so you can work with all the goodies of the Scala 2 compiler. We have some alias, no, like string call, integer call, long call, array call, etc. We have the classic way to create a literal that is in the Spark, no, like this one, and it will provide you, because we will see exactly that this is an integer. Also, we like in Doric to make it more Scala flavored. No? So we provide you with this extension of methods. Then when we have this Doric column, we have the select method. It's not the original select method, as you can imagine. It's an extension of DataFrame, but we are trying to always make your code compatible with the original code of Spark. No, you don't have to use a new structure. No, you don't have to use a new container. We only are typing the columns. No, so we have the select, we have the column with column, and also we have the filter. And in this case, for example, the filter for sure will expect a Boolean column. No, in this case, column 1 and literal 1 are both integers, and if they weren't, they will have a runtime error. So we are refining, we are trying to make a little bit restrictive our API, but in a way that it's logical. No, a filter should be a Boolean column. Okay, so also we try to make reusable your code if you're already using Spark with DataFrames and you want to use a little bit of Doric. Okay, you can get your column, for example, and use the asDoric method to type your column, no? Your untyped column. You can type it here with asDoric and the type, and it will work again, and it will expect that the return of this column reference will be a string, and it will validate you in runtime. Okay, I'm going to talk a little bit about casting, because we already see the case of the addition between the integer and the string. In Doric, we wanted to help you. There are some cases like the implicit conversions. I quite logic. No, for example, if we have a long plus an integer, okay, we can do the whole code by ourselves. But we allow you to, for example, make some implicit conversion that we call safe. No, that are those that will never return a null. In this case, for example, long plus an integer, what we are going to do is transform this integer into a long, and we can addition between two longs, and the result will be a long column. But in the cases that we can have nulls that are a little bit tricky, we have this unsafe cast. And we are not allowing any implicit conversion for a safe cast because we want the developer to be conscious that they're making this transformation and they can have a point where a null can start to propagate among all your results. Now you have to make an unsafe cast to integer. Now everything that you want to from string to whatever is going to be an unsafe cast. I'll tell you, we want to give the developer much power, much knowledge of what is happening in their code. Okay, so another thing, for example, in Spark, we have when, as we have in SQL. But the way that is created in Spark is not very good. So we made, we are talking that we are using a real language, real programming language. We have the builder pattern, for example. So we made the when. It suits very well with the builder pattern. Now, for example, it is when we know that we are going to return integer, and then we will expect that in this case, something Boolean, we will return this value, no? That is will be exactly what we are expecting, no? This has to be an integer. If not, compiler. Okay, the same for here, no? Another Boolean, and in otherwise, we can put a default value, or we can also have an otherwise null. Another case, we will return a null. But you are going to know that if these two cases are not fulfilled, you will return a null. That is very good to be aware. Okay, Spark introducing 2.4 and improved a lot in 3.0, 3.1, 3.2, etc. versions. Introduce higher order functions in their own way. It's not higher order functions from Scala. They are higher order functions for Spark. In this case, they are higher order function that goes from column to column. From column to column, we are talking about higher order functions. We can do it better with Doric, no? In this case, for example, we have this collect list. It's an aggregation that we are doing from an integer column. And we know that the return will be an array of integer, no? A Doric column of array integer. And we can apply these higher order functions. In this case, if we apply a filter, we will know that this underscore will be an integer, no? So we can compare it against another integer, and we will have a compile error if we are not doing something that it's logic, no? It's something that it's valid. Also, we can have this aggregate. No? It's like a fold left. We start from 0, we go to add all the elements that are bigger than 5 in this case, no? We can also do it this way. Spark DataFrames, they like to have this method not in a dot method way. They like to pass parameters, no? So you start to have your code like a nested nightmare. And if you want to do something complex with these higher order functions, it's quite tricky. So I think that with Doric, we made an improvement. We have the validation in the compiler. Everything will work as we expected. And also, we can write it in a more readable way, no? From left to right, from up to down. It's a great way to work. Okay, in Doric, we allow you to choose the amount of sugar that you can use. For example, as we saw, part of the sugar is already the castings, if you want to make them explicit. But you can also, for example, have some cases like the literals. You can .lit, or you can make this literal conversion. And also, we have a combination that if you want to make this integer become a long and can be accepted, you have to import this another implicit conversion. Okay, so it's going to be very fast. We have also interpolators. It's something that Spark doesn't give you, and it's pretty great to have it. You expect only or literals or string columns, so you have to make the castings by yourself or make it implicit. Okay, this one I want to not go so fast because we introduced the idea of types in the columns. So why not introduce some logic to have branching depending of the type of your column? No, we were being showing examples that we expect a string or anything else, no, or we will have an error. Maybe, yeah, we will expect a local date, and this is going to be the return type. But in case of that is a local date, okay, so we keep it as it is, no, the identity function. Maybe in the case that it's a string, we will parse it with our standardized format of date in our company, no? So we can have this, and in other case, an error. So it's a great function because we can provide to everybody saying, okay, if you want to be sure that it's a local date, you have to use this function. If this function, it gives you an error, it won't be a proper date. But if you have the proper date, okay, so you have to use this, and it's reusable, something that is quite good to have. Also, this typing, we want to use it as much, and we try to start to make Doric like a good interface to work putting things inside and taking things outside of Spark. And I think that it's a simple example, but it's a good one. No, everybody has like codes, no, when they working with data. In this case, for example, we can make that, well, for example, the status of a user, if it's single, it's in a relation, it's married. And with single, we can represent it with 1. No? Relation is 2 and married is 3. No? It's something quite typical using relational databases. So we can make implicit conversion that will know how to transform these values, no, these objects, these algebraic data type, into Spark. No, so here we don't have the code exactly how it's done, but it's quite easy. It's a simple pattern matching one way and the other. No, a single is 1 and 1 is single. Relation is 2, 2 is married relation. But we can make code like this. For example, this one, no, that we say, okay, if the user state is equal to single, we will have this score, for example. No? We will expect this column score, that is an integer, and we will multiply by 2. If the user state is a relation, we will multiply by 10. And otherwise, we expect that it's going to be married, we will multiply by 12. Don't think about the real use of this function. But I think that the code is not 100% SQL. It becomes something more Scala and to work with. Something that we really like. And also, this is a tricky part. We have a lot of discussion when we were developing this. Because, well, we say, okay, Doric, we want to make the middle way, no, of typing. We want to be very dynamic, okay, but we want to be a little bit static. So how can we work when we are talking about structures, no? Spark, you can have a column that it can contain subcolumns, no? Or that column can be a user, for example, no? It will have a subcolumn user.name and a user.age. And how we have to work with this when we are talking about Doric. So we wanted to not have a fight, and we make both. Now we have a structured one. No? We can say, okay, this column is a user. This user is a name and an age. We can make this with shapeless and the use of macros. And when you want to get a child, no? For example, we can get child.name. It will work. You already know that this user name, it's a string, so it will work great. But we still have to provide to the people a dynamic way. So we have this row. You already will remember that data frame is a data set of row. Row is in the first level, no? Each column, it's part of a row, but also the columns can be a row. So we will have a different way to extract them, that is get child of type string and name. What will happen if we don't have the user? Okay, the same as you already have. If the user is not a struct, okay, the user is not a struct column row, but if it's exists and it's of type row, and we try to get one of the children, we will do the same. No, we will try first to see if we have the name, and if it exists, we will see if this subtype, no sub column, is of type string, and it will give you here is the real source of your problem. Not here. This works. This one. So we will have a great help from Doric to fix our errors, and we still can work the way we want, no? In a more static way inside the columns, or a very dynamic way using rows. And the last element. This is a brief snippet of a project that we did and we are still using. In this case, and I want to show you the real benefits of Spark, of Doric. We have a project that, well, there were some people making models. Models are big tables with a lot of data, and we wanted to filter them in a way that it was readable, reusable, and that somebody that maybe didn't have any kind of knowledge of Scala or Spark or could read it a little bit and understand it. No, the project was previously made with rows. So if you see that it has like a rule listic syntax, it's because it comes from do. We did a transformation from rules to this kind of way to work, and it's a way that, well, we wanted to have a rule, some text to explain what was happening here, the word when, and here we are expecting a Boolean column at the end. No, and the way that we work here is like, okay, you can make these small pieces of code that you can merge into a larger chunks, and in other parts of the system, they will run these filters against the data frame, but you're not going to touch here the data frame. So Doric helped us a lot to improve the readability of the errors, for example, because when we have an error in the other place of the code, we always have a pointer to the real source of the error. No, if this machine KPI was not there, they changed the column name. It was not a float, they changed it something. We will have an error here, and it will point it. Okay, in this line, you have to fix it something, or what they are giving to you is not according, and you have to talk to your data steward, tell us to fix it. And it was a great advantage to make that nobody could write here code that was illogical. It was type checked. It was a Boolean for sure. It was pretty neat. And this is a very small example of the utility of Doric. So, well, some highlights. It's very similar to the Spark syntax. So if you're already a Spark developer, you will work with it quite fast. You can reduce your previous code and make only the changes needed to use Doric. Well, with the cast, you can control your code. The syntax, you can choose whatever the way that you want to do. Well, the current state. No, Doric, right now, you can use it from 2.4.1. 2.4.2.0 is not a real version of Spark. It was like a mistake that they released, to the latest version. So you can choose your version of Spark. It's tested against all those versions, minor, major, and middle versions. We have almost all the Spark API. We are even creating new functions that I didn't have to tell you here that improve even better what you can do with Spark. And the latest version is 0.0.5. It has a small bug that is not about that you will find in runtime. It's something that more related to the completion of IntelliJ that I will give you, that we will fix it in the next weeks. Future, well, improve the syntax, improve the sugar, make some testing utilities. We have a huge list of things that we want to do, and we don't have time. More information, applabs.com/Doric on GitHub. Go to the applabs/Doric website, You have the code. We accept everybody. We already receive a great collaborations, and we are expecting yours also. So, well, thank you for the time. I don't have more time, so I don't want to bother you. Thank you all.
Fire in retro rock.
Roger, Matt. Ready to eject.